This is section 3.5, box plots for displaying summaries. So we're going to go through and talk about what a box plot is, how to create one, and some of the positives and negatives for box plots and what they can do for us when we're analyzing our data, or at least summarizing our data. So the following data set contains the ages for the players on the 2015 New England Patriots. Let's use this frequency table to answer the following questions. So here we have a frequency table, and just a reminder that these are our ages here, as it's labeled right here. So we have ages ranging from 22 to 38. This row here contains our frequencies. Okay, so 8 players are 22 years old. So what do we suspect the shape of the distribution is? So of course that's always easier to do if we can see it graphically, but looking at the table we see, okay, there's 8 at 22, 10 at 23, 8 at 24, so 18 players at 25, and then we kind of trickle off a bit. We go down to having 6 players, 3 players at age 30, 3 players at 31. It looks to me like this would be skewed right. So we'd have a tail going off in the right direction. Find the mean age. Okay, so this is a review of some of the things we've done before. What we want to remember is that we're dealing with a frequency table. So to find the mean age, we want to add up all the ages of all the players. And if we add up this row here, we get n equals 80. 80 players are contained in this chart. So we need to have 80 ages. So the one way we can do this is that we're going to add up 22. We have 8 players with the age of 22, so we can multiply 22 times 8. Then we're going to add up all the players with age of 23. That's 10 players, plus the players with age of 24, 8 players, and so on, all the way till we get to the age of 38, in which we only have 1 player. This will be over the total number of players. So we can do this calculation, and we come out to be 25.9 years. Find the median age. Okay, this is a good review of all of our, these are both measures of center. The median age, so this is a big table, so we don't want to list them all out. This is when it's good to use our n plus 1 over 2. This tells us the position of the median. So we have 80 plus 1 is 81 over 2, gives us 40.5. That is not the median, but that is where we can find the median. So at the 40th, so we're going to be between the 40th and the 41st value. So let's look at our table up here. Oops, I forgot that's the highlighter. Let's try that with this. We have 8 at 22, then we're up to 18 total when we go through the 23s, plus another 8 gives us 26 at age 24, and then we add on 18 more to 26, so we end up at 44. So inside of this column of 25s, we find that our median age is 25. So that value that we were looking for, the position, is in that group right there. Now to find our first quartile, we're going to be thinking about the first 40, because we're going to split the first half and find the median of the first half. So there's 40 observations in the first half. 40 plus 1 divided by 2 gives us 20.5. So we're going to be looking for the value between the 20 and the 21st position. So again, we're looking up here, we have 18 here. And so inside this next group of 8, we're finding the 20 and 21st, which means our first quartile is 24 years. And again, to find the third quartile, we're also going to be looking at the second half of the data. It's going to be in the same position in the last half of the data, the second half. And we could go from the other direction in to find it. So starting here, looking between the 20 and 21st. So we go over 4, 7, 10, 16, 19. So inside of the 27 values, we'll get to the third quartile. So the third quartile is 27 years. Okay, so the minimum age, we saw that up on the chart, that's 22 years. The maximum age is 38 years. Find the range. Our range is always our maximum minus our minimum, which is 38 minus 22, which becomes 16 years. Find our IQR. Remember, our IQR is equal to Q3 minus Q1. We've already calculated those two things. Our Q3 was 27. Our Q1 was 24. So that's 3 years. Remember, the IQR measures your middle 50%, the spread of your middle 50%. So there's another way to summarize your statistics. It's called the 5-number summary. Okay, and so a 5-number summary always contains these values: your min, your Q1, Q2, Q3, and your maximum. So our 5-number summary is 22, 24, 25, 27, and 38. Okay, so let's look at the next page. The dot plot below shows the location of the quartiles, Q1, Q2, and Q3. So here's Q1, Q2, and Q3. Remember that Q2 is the median. It splits your data in half. So 50% is less than that line, 50% is greater. Okay, and so this is price of gas in Austin, Texas. Excuse me. So a way that we can graphically show the summary of our data is called a box plot. And it shows the 5-number summary. And so this is the box plot of the gas prices. And a box plot has some key features. So these are its whiskers. They extend out. They extend to the minimum and maximum value. Okay. The Q1 is always this left part of the rectangle, and Q3 is the right part. So over here I have Q1, this is Q3. And so remember that the IQR is the difference between Q3 and Q1. So the IQR is the length of your rectangle. And the last piece of information that's also on here, I just kind of covered up, was this line here, which is Q2, which is equal, remember, to the median. So 50% of your data falls below that, 50% above that line there. Let's see here. So that's all those bullet points I just mentioned. Does the box plot give us as much detail about the distribution of the prices? It doesn't give as much about the distribution. Like we can't see peaks in the distribution, and yeah, we lose some of the individual values. We can't see all the observations. I'm scrolling back up to the dot plot. So we can't see all the observations, but it does give us a good visual of our 5-number summary, and that is often going to be useful when we're comparing two distributions. So the next page says, draw a box plot for the distribution of ages from the New England Patriots. So we just wrote our 5-number summary on the other page. So let me just jot that down because this is the key information that we need. 22, 24, 25, 27, and 38. Okay, so I like to usually start with my rectangle here that's going to go from my Q1 to my Q3. So at 24 to 27, that's my Q1 and Q3. Then I can put my median on, which was at 25, and now extend my whiskers out to my minimum value. Kind of went a little overboard there to 22. And my other whisker is coming all the way out here to 38. Okay, so that gives us a look. If I was creating this from scratch, I would also have to remember to put my label and also have a consistently scaled axes here so that people could read it. So right below this is our dot plot. I can't put those on the screen, but what are the differences and similarities? So we can't necessarily tell that the distribution is skewed right from the dot plot as we can, I'm sorry, from the box plot. We can tell it's skewed right from the dot plot. We can also see potential outliers here. We're not able to necessarily know whether or not we have potential outliers in the box plot, and we can see a nice peak at 25. So we have a mode peak at 25 years. So because we up here we know that the data is like these are each 25% of your data, each of these things. So about 20 players' ages are here, and 20 players are here, and 20 players' ages are here, and 20 ages of players are here. We don't know, like we know there's an age here because a whisker extends there, but are there like ages like all along here? Or maybe, you know, they're all over here and just that one is extended out there. So we can't see that. That kind of information gets lost on a box plot, whereas we can see it on a dot plot. So that was kind of, I answered that question up there by looking at the graph. So here is one important feature that we can do, is that we can calculate an outlier test to identify potential outliers. So the outlier test is one way to identify potential outliers. And we use these following formulas. Now notice these formulas are giving us cutoffs so that we can find out whether there's data points outside. Like if there's data points lower than the lower cutoff, they would be potential outliers, or data points greater than the upper cutoff. So the formula isn't too tricky. It's Q1, we know that, minus 1.5 times our IQR. So these are all things that we've been working with, and then the upper cutoff would be Q3 plus 1.5 times our IQR. So first, let's calculate our lower cutoff for the Patriots. Q1 is 24 minus 1.5 times our IQR, which was 3. We calculated that on the first page of the notes today. That comes out to be 19.5 years. So now we're going to see, are there any ages that were below 19.5 years? No, the lowest age was 22, so no lower outliers. Then we can calculate our upper cutoff. That is our Q3, which was 27 minus 1.5 times 3. This comes out to be 31.5 years. And we ask, by looking at the data set, were there any ages above 31.5? Yes. There's actually potential of 4 high outliers. So outliers in this data set would be below 19.5 or above 31.5. So let's look at what that would look like on a box plot if we took into account outliers. So a box plot that shows outliers is called a modified box plot. StatCrunch can create either one. You can determine that by picking that box in StatCrunch. Sometimes, just to note, someone says, oh, here's a box plot, and it doesn't say here's a modified box plot, but you see these points out here that indicate that there are outliers, and so you'll just know, oh, they're actually giving me a modified box plot. So just that's kind of a point of information. So a modified box plot is modified to demonstrate that there are outliers. So the whiskers go to the last data point that's before the cutoff. So since there were no lower outliers, this is still going to our minimum age, 22. And this line here, this whisker, is going to the last data point that's less than 31.5. That turns out in our case to be 31 because there was players that were 31 years old. So, and then looking at our data set, there's only one outlier shown here, but in reality, 3 players had an age of 32. So sometimes those are kind of hidden because they're piled on each other. And then finally, we have this other outlier out here, of course, that's age 38. Okay, and anytime we find some potential outliers, what should we do with them? And the first step is always to investigate. Here are some scenarios about outliers. An outlier might not be an outlier at all. So for example, we might see something like this graph here where, okay, the modified box plot showing us we do have one outlier on there, one potential outlier. But if we look at the histogram, we're starting to realize, well, this data is actually kind of just skewed a little bit to the left. There's no big gaps between the bins. So it's really maybe not an outlier at all. Another scenario might be that the outlier might tell you something interesting about the data set. So for example, these graphs here about fuel economy of 2010 model sedans from Ford, Toyota, and GM, they both suggest 2 potential outliers, both the histogram and the box plot. So here are the 2 potential outliers in both of them. And maybe this isn't, this is because maybe there's something different about these 2 sedans, and maybe it turns out maybe they're both hybrids or something that increases their fuel economy. Okay, another scenario is the outlier might be a result of a clerical error. So this sounds like a little concerning, but it's definitely possible. If you were to see this graph of New England Patriots ages, and we looked at it and we see this one outlier out here, age 70, that's probably not right. Maybe there was a typo or someone didn't read something right. A lot of times data is collected by hand or typed in, and that can happen. So a person would verify this. Is this an accurate data point? And if it's not, it could be fixed before the analysis actually began. So box plots can be drawn horizontally or vertically. I like the horizontally ones personally, but StatCrunch, you can do either one. The axis is going to use a consistent scale. It's a display of our 5-number summary, which is our min, Q1, Q2, Q3, and our max. And so the box extends from Q1 to Q3, so the length of the box is really our IQR. The whiskers extend to minimum and maximum values. If you use a modified box plot, then there's potential outliers that are denoted by dots. Sometimes I've seen asterisks. And box plots are extremely useful when comparing two distributions. You can see whether the medians are different or whether the spread is different. But we have to be careful because they can hide some interesting information about a distribution. So that's the end of chapter 3.